Have you ever wondered who could possibly be behind the discovery that changed the course of our world, splitting the atom? What if I told you it was a woman whose groundbreaking work during a time of extreme adversity led to one of the most significant scientific breakthroughs of the 20th century? Yet her name often remains overshadowed in the annals of history. This is the story of Lise Meitner, a physicist who helped unlock the mysterious power of nuclear fission. Stay with us as we delve into the life of a remarkable woman who not only shaped the foundations of atomic physics, but did so while battling against the tides of gender bias in the echelons of scientific research. Lise Meitner was born in 1878 in Vienna, Austria, into a family where education was highly valued. Despite the societal norms of the time which often restricted women from pursuing advanced studies, Meitner's passion for science could not be quelled. At a time when women were largely excluded from academic roles, Meitner became one of the first few women to attend university in Vienna. She not only attended but excelled, obtaining her doctoral degree in physics in 1906, a rare feat indeed. But the road was not easy. Meitner had to fight for her place in every laboratory, classroom, and discussion. She often found herself the only woman among men who were not ready to accept a female colleague. Her early career was marked by perseverance and dedication as she navigated through these academic and social challenges with unwavering resolve. It was her indomitable spirit that would later lead her to Berlin, where she collaborated with chemist Otto Hahn. Together, they embarked on research that would eventually change our understanding of the atom. However, the path was fraught with obstacles, not just in the world of atoms and particles, but in the very human world of prejudice and resistance. In the bustling city of Berlin, Lise Meitner found an intellectual companion in Otto Hahn, a chemist who shared her curiosity about the atomic world. This partnership, formed in the early 1900s, was not just a meeting of minds but a fusion of chemistry and physics that would pave the way for astonishing discoveries. Meitner and Hahn were stationed at the Kaiser Wilhelm Institute for Chemistry, where they began experimenting with radioactive elements. Their work was pioneering, often venturing into uncharted territories of science. Despite the prevailing gender biases of the era, which often marginalized her contributions, Meitner's expertise was indispensable to their joint experiments. Their collaboration was marked by mutual respect and intellectual parity, a rarity in an age where women scientists were often sidelined. Together, they investigated the properties of uranium and thorium, unknowingly inching closer to a discovery that would shake the very foundations of modern physics. It was a partnership that defied not just scientific norms but also social ones, setting a precedent for future collaborations across the gender divide. The year was 1938, and the world of physics was about to be turned on its head. Lise Meitner, now working remotely due to her forced emigration to Sweden amidst growing political tensions in Germany, continued her correspondence with Otto Hahn in Berlin. Together, they delved into the results of an experiment that Hahn had conducted, which involved bombarding uranium with neutrons. The outcome was puzzling. It suggested the uranium atom had split into smaller, lighter elements, a notion that contradicted existing scientific beliefs. In a flurry of letters exchanged over snowy borders, Meitner and her nephew, physicist Otto Robert Frisch, analyzed Hahn's results. Through their calculations, they came to a stunning conclusion. The uranium nucleus, when bombarded with neutrons, could indeed split into two. This process released an enormous amount of energy, illustrating Einstein's equation E=mc² in a tangible, powerful way. This revelation was monumental. It was not merely a scientific discovery. It was the opening of Pandora's box that would eventually lead to the development of nuclear power and nuclear weapons. Meitner, often referred to as the mother of the atomic bomb, profoundly understood the implications of their work. Yet, she remained a proponent of peaceful scientific pursuit, grappling with the ethical dimensions of her discovery. The term nuclear fission was coined by Frisch, inspired by the process of cellular division in biology. It was a simple term for a complex phenomenon that had changed science forever. In 1944, the Nobel Prize in Chemistry was awarded solely to Otto Hahn for the discovery of nuclear fission, a decision that sparked one of the most significant controversies in the history of the awards. Despite her crucial role in the discovery and her theoretical interpretation that led to the understanding of the process, Lise Meitner was inexplicably left out of the accolade. This omission was not just an oversight. It was a reflection of the gender biases that permeated the scientific community at the time. Meitner herself reacted with grace and dignity, continuing her research without bitterness. However, the exclusion highlighted the struggles faced by women in science, especially those who contributed profoundly to their fields only to be unrecognized by their peers. The scientific community and later historians have debated the fairness of this decision. Many argue that Meitner's exclusion was a grave injustice, overshadowing her substantial contributions to nuclear physics. In response to this, the term Meitner effect has been coined to describe the frequent overlooking of female scientists in award recognitions and academic honors. Despite the Nobel snub, Meitner's legacy continued to grow, and she received numerous other honors reflecting her status as a pioneer in nuclear physics. Her story is a stark reminder of the need for greater equity in scientific recognition and the ongoing challenges that women face in the field. As the shadows of World War II spread across Europe, the implications of nuclear fission's discovery became starkly clear. Countries raced to harness the power of the atom, and the potential for atomic weapons became a horrifying reality. Amidst this, Lise Meitner stood firm in her ethical beliefs. Despite understanding the immense power her discoveries could wield, she categorically refused to participate in the development of nuclear weapons. Her stance was clear: science for progress, not for destruction. During the war, Meitner remained in Sweden, where she continued her research and took on a role somewhat akin to a scientific advisor, albeit informally. Her correspondence with scientists around the world didn't just include discussions on nuclear physics, but also pleas for rational and ethical use of scientific discoveries. Her influence extended beyond her immediate circle. Meitner was consulted by the Allies and was even invited to join the Manhattan Project, the U.S. government's secret project to develop atomic bombs. She declined, reiterating her belief that science should not be used as a tool for war. This decision marked her not just as a brilliant physicist, but as a scientist with profound moral integrity. Post-war, Meitner continued to advocate for peaceful applications of nuclear energy, contributing to developments in nuclear medicine and energy production. Her legacy in these fields is profound, showing that her impact went far beyond the laboratory. She was not only a pioneer in physics, but also a guiding light in the ethical debate over the power of the atom. Lise Meitner's later years were marked by recognition and reflection. After the war, she continued her scientific work and mentorship, though she never returned to Germany, remaining in Sweden until her death in 1968. Throughout these years, her contributions to physics were increasingly celebrated, albeit somewhat belatedly. Universities awarded her honorary doctorates, and she received numerous accolades, such as the Max Planck Medal and the Otto Hahn Prize, recognizing her pivotal role in the discovery of nuclear fission. Yet, perhaps more significant than these honors was the growing acknowledgement of her moral stance during the war. Meitner's decision to oppose the weaponization of nuclear physics became a cornerstone of her legacy, influencing generations of scientists on the ethical implications of their work. Posthumously, Meitner's impact has only grown. Elements have been named in her honor. Meitnerium, a heavy element, stands as a testament to her legacy in the periodic table. Schools, streets, and institutions around the world bear her name, and she has become a symbol of perseverance and integrity in science. Documentaries, books, and films continue to explore her life and contributions, ensuring that her story inspires future scientists. Lise Meitner's journey from a physicist working in the shadows to a celebrated pioneer of ethical science is a powerful reminder of the role of determination and integrity in achieving lasting change. Her life challenges us to think about how the boundaries of science are not just defined by what we can discover, but also by what we choose to do with that knowledge. As we reflect on the extraordinary life of Lise Meitner, we are reminded of the profound impact one individual can have on the world. Her story is not just one of scientific breakthroughs, but also of moral courage and determination. Meitner's work on nuclear fission not only paved the way for advancements in energy and medicine, but also posed significant ethical questions that continue to resonate in the scientific community today. What does it mean to be both a scientist and a steward of the powerful tools we create? Lise Meitner's legacy teaches us that the pursuit of knowledge is intertwined with the responsibility we hold towards humanity. Her refusal to participate in the development of nuclear weapons stands as a powerful testament to her integrity and her commitment to science for the betterment of society. As you go about your day, consider the role of ethics in innovation. How do we balance the pursuit of scientific advancement with the potential consequences of that knowledge? Lise Meitner's life challenges us to think critically about these questions and to strive for a future where science and ethics are inextricably linked. Thank you for joining us in exploring the life of Lise Meitner. If you found this story inspiring, don't forget to like, subscribe, and click the bell for more stories of remarkable individuals who have shaped our world. What part of Meitner's story struck you the most? Let us know in the comments below.